Okay, welcome day 2, chapter 8.3 AP Calculus. We're finding volumes using a discs and washers techniques. Basically a disc would just be a very, very short cylinder, almost a circle, and a washer, there'd be a hole in it. So we did that on day 1 as well. So find the volume of the solid generated by revolving the region bounded by the lines and the curves about the x-axis. So we're bound by these, so let's get a picture. So y is 0 and x is 2, and this is going to be positive, so I'm going to draw this down here. So I am bounded by y is 0, this one. I'm bounded by x is 2, this one. And I'm bounded by y equals x squared, so that's just our typical old parabola. By the time I would get over to x is 2, put in 2, I'd be up at 4. So we're going to look like this. So we're bounded. The area we're looking for is in this region. And now we're to find the area, should we rotate that about the x-axis. So if I rotated that about the x-axis, we'd end up with this same area down here. And we'd have this area, but if we're rotating that around there, this is just a disc. There's no hole in the middle of it, so a little bit easier here. So what we want to do is we want to say our discs, if we looked at this rotationally, we would just have these little circles. So what is our area? Our area of the circle is pi r squared. But what is our radius is our height. And what is our height? Our height is y, and what is y? Y is x squared. So our area is pi x squared squared. And what are we letting the values of x run from? From 0 to 2. So our area equals the integral from 0 to 2 of pi times x squared squared dx. Or pi times integral 0 to 2 of x to the 4th dx, which of course is pi times, that wants to be x to the 5th, but it's divided by 5. And we always double check that, take the derivative moving backwards, and we've got it. And that is from 0 to 2, so that is pi times 2 to the 5th, 32 on 5, minus, just distributing the pi times 0, or 32 on 5 pi cubic units. Okay, not too bad. Hopefully there's some understanding going on there. If not, you've got plenty of time for questions on this. Okay, so now we're bound by a little tougher here. We've got a couple of curves to look at. I know this is always going to be positive. I know this is going to be, if this is going to be positive, we're going to be interested in the positive portion of this. But I'm going to leave room for my rotation about the x-axis. So I'm going to draw this up here. And let's take a look what we're dealing with here. When x is 0, I get 1. When x is 2, when x is 2, I'm going to get 4, and I'm going to get 5, and I'm going to get 5. So that's a biggie for us. I think that's going to be helpful. So when x is 2, I think we're interested in that region right there. Let's start putting some points in. X squared plus 1, put in 0, put in 1, put in 2, and we're up at 5. Put in 0 for x plus 3, and I get 3. I move up 1 over 1, and sure enough, we're up here. So we have this region. And this parabola is going to come back up as I move to the left. Is going to come back up to here. And this is going to come down 1 over 1. So there is our region, which we would be rotating, and we'd be getting something along the lines of this when that thing is rotated. So here's the key. When we rotate this, we've got a hole in the middle. Therefore, this is a washer. So our area of our cross-section, our area of our washer, is the area of the big circle minus the area of the little circle. Nice notation to use, really clear to the reader. And we know that those are circles, so that is pi, I'm going to go capital R squared for the big, minus pi lowercase r squared for the little. Another good notation, a good habit to get into on our washer problems. Okay, so our big radius is the radius that gets us up to here. And that radius, at any point on it, is our height. And what is our height? Our height is y. And what is y? Y is x plus 3. So this is equal to pi times x plus 3 squared minus pi times our little radius is this guy, and that is x squared plus 1 squared. Okay, we all right there? All right, so we got a little bit of algebra to do here. I'm going to go ahead and set up our integral now. So our integral, I'm going to factor out pi. It's a constant, we can do that. We're running from -1 to 2. And I get, let's FOIL this, I get x squared plus 6x's plus 9 minus all of, FOIL this, x to the 4th plus 2x squared plus 1 dx. And we could go ahead and integrate that now, but we probably have some like terms we can combine. So I get pi from -1 to 2. Let's see, I've got a negative x to the 4th. I've got an x squared minus 2x squareds. So a minus x squared. I've got a plain old plus 6x, and I've got a 9 minus a 1 plus 8 dx. Look all right? Okay, so when we integrate this guy, we get pi times, whoops, I'm done integrating, pi times, I get negative x to the 5th on 5, I get minus x cubed on 3, I get plus 3x squared, I get plus 8x, and all of that is from -1 to 2. Double check, make sure I'm on track here. That looks good. And then, obviously, we substitute 2 in, we substitute -1 in, we show all that work, and I'm going to leave that to the reader. We should end up with 117 on 5 pi cubic units. Okay, by this point we know how to get out of this. All right, let's take a look at C. We've got secant from -pi on 4 to pi on 4, and we've got the horizontal line, just y equals √2. Well, secant is built off of cosine, so here's my little thought bubble. Cosine looks like this, but this is pi on 2 already, so pi on 4, we're just this part of it, to -pi on 4. So this is the portion of secant we're dealing with, right up here. So I'm going to draw that. We're pi on 4, -pi on 4, at 1. We're just starting our ascent. We haven't reached the asymptote yet. Now, what is cosine of pi on 4? Cosine of pi on 4, we should know it, but if you don't know it, this is a 45, 1 √2. That is 1 on √2, so secant of pi on 4 is √2. Oh, perfect. So we are dealing with this curve. I'll make it in red to distinguish it from my axes. And this is √2 right here. So when we would rotate that, we would be down at -1 here. We would look like this when that guy's rotated. So what are we dealing with here in our rotation? We definitely have a hole here. So here we go. We're going to get in this habit. Our area of our washer is the area of the big circle minus the area of the little circle. And the area of the big circle as we go around is pi r squared, big R, minus pi little r squared. But our big R is this height, which is just √2. So that is just pi √2 squared minus pi times our little r is any height along here, and that is y, but y is secant x. So pi secant squared x. So we're ready to integrate this thing. So we've got integral, x runs from -pi/4 to pi/4 of, I'm going to factor the pi out, square root of 2 squared, that's just 2, minus secant squared x dx, or pi times 2x minus tangent of x from -pi/4 to pi/4. And I think I'll stick with you and wrap this one up, although I think we should be good here. We end up with pi times, I put pi/4 in, 2 times pi/4, pi/2, minus I put pi/4 in, pi/4 tangent 1 to 1, 1, minus I put -pi/4 in, I get -pi/2. I put -pi/4 in. Tangent of -pi/4 is -1 minus -1 plus 1. So where are we at here? Pi times, I get a pi/2 plus another pi/2 pi. I get a -1 minus another 1 minus 2. So we end up with pi squared minus 2 pi cubic units. After all, we're finding values. Okay, kind of rewarding when you get those done and you look in the back of the book and you got the correct answer. Example 2, find the volume of the solid generated by revolving the region about the y-axis. The region is enclosed by, all right, this one starts out looking a little bit ugly here. X equals 0, y equals -1 to 1. My x values are always going to be positive, I see, so I'm going to set this up this way. Let's see what we've got here. All right, y is going to be, if this is 1, this is -1. Here's one of my boundaries. Here's one of my boundaries. X equals 0 is a boundary. And now I'm going to just start picking some values for y. When y is 0, x is 0. When y is 1, and that's the last thing y can be, when y is 1, x is square root of 5. So that would be right over here, square root of 5, we're up here. And I think we understand this is a sideways parabola. Looks like this. When y is -1, it's the same as when y is 1. So if we're enclosed by all of those, we're talking about this, and now we're revolving about the y-axis. About the y-axis. So as I rotate this around this way, there is no hole in the center. I mean, I guess, yeah, there isn't even a hole at any point in the center. We just, once that guy revolves around, we're looking at this, a little spool, kind of. Okay, so that means we just need that area. So our area is, our area of any single cross section is just pi, is just a circle as we rotate that around, is just pi r squared. but what is r? R at any point on there is our x value. But what is x? X is square root of 5y squared. So our area is pi times square root of 5y squared squared. That's our radius. Square it. Or we get 5 pi y to the 4th. And we are ready for our integration. All right, so we want the integral. Now the y's are running from -1 to 1, and we need, I'm going to factor the pi out. I'll leave the 5 in here. I think you can see why. Just a little anticipatory. So this is just pi times y to the 5th. Y to the 5th's derivative is 5y to the 4th. So we've got it from -1 to 1. Wow, that cleaned up really nicely. And we get pi times 1 to the 5th minus pi times -1 to the 5th. That's just pi plus pi 2 pi cubic units. Well, that worked out well. All right, next one, make sure you check this out. Should have the word by in here, pretty important part of this. The region of the first quadrant bounded above, it's not really bounded above the parabola, it's bounded above by the parabola, so this would be a top bound, and below by the x-axis, and on the right by the line x equals 2. So let's take a look at what we've got here. I'm going to go ahead and draw this guy. On the right, by x equals 2, we've got y equals x squared. So y equals x squared. So we're on the right, bound here, and bound above by the parabola. By the time I get over to 2, this parabola will be up to 4. So we've got this. And as we rotate this guy around the y-axis, we can see we've got a hole in here. We've got a part between here. We didn't have that issue up there. We've got a hole in here. So I need area of our washer equals area of the big circle created minus area of the little, or pi big R squared minus pi little r squared, or pi times big R is 2. Little r is any of these x values. But what are our x values? Our x value, x is equal to square root of y. We need to put square root of y in here because we're rotating about the y-axis. So that is pi times square root of y squared. There's our little r. Again, rotation about the y-axis, we need dy's here. So we need to have this in terms of y. So we get 4 pi minus pi times y. Therefore, our integral, the y values go from 0 to 4 on this rotation. And we have, I'm going to factor out pi, I get 4 minus y dy, and we're home free here. I get pi times 4y, that equals, minus y squared on 2, from 0 to 4, love 0 there, so I get pi times 4 times 4, 16, minus 16 on 2, 8, minus 0, like that 0 because both have terms of y in it, and that is just 8 pi cubic units. Ooh, so sorry I didn't bump that up for you. I got so caught up in it. I'm going to leave that on there. Again, hopefully once we get to this point, though, we have it made. integral 4, 4y, integral y squared on 2, put in 4, put in 0, we get 0, 0, don't need to do it, so we end up with 8 pi cubic units. And there is your assignment that goes along with this. I don't think you can make an assumption that, well, I've seen these, it made sense to me, I'm going to be in good shape. You're going to have to get some practice on these. So things to keep in mind. Rotating about the y-axis, our integral is going to run from the y distance of the graph, from 0 to 4 in this case, from -1 to 1 in there. Integrating about the y-axis, we need terms of y and dy. We need terms of y and dy. In this case, I already had what x equals. Again, x is our radius here. I already had x in terms of y. In this one, I had y is x squared, so I had to go ahead and say, all right, x is square root of y. Should it be plus or minus? Well, the radius would be a positive value, so we're just going to use the positive in that case. All right, there's your assignment, and let's get after it.